Hello my dear friends, welcome back to our YouTube channel ADC Max. In this class, we are going to see the second sum. R minus 6s plus 9t is equal to e to the power 3x plus y. So what is RST? So do you remember RST are the three standard second order partial derivatives notations. So what is R stands for? R stands for dou square z by dou x square, isn't it? So what about dou by dou x is nothing but d. So d square z. Similarly, s is equal to dou square z by dou x dou y. So dou by dou x, dou by dou y. So it's equal to d dash z. What about t? T is equal to dou square z by dou y square. So what about dou by dou y stands for d dash. So d dash square z. So let us rewrite RST in terms of d dash, right? So what is R? D square. What is S? D dash. What is T? D dash square. Z is the common one. Is equal to e to the power 3x plus y. It's clear? The second order partial derivatives. So let us get the complementary function from the left hand side by replacing d equal to m, d dash equal to 1 and assuming the right hand side 0. Why? Because this time right hand side we have some non-zero term. This will generate the PI, particular integral. Let us see the separate case. Right. Now, after replacing d by m and d dash by 1 and assuming that right hand side is 0, we get the auxiliary equation is m squared minus 6m plus 9 equal to 0. If I solve this equation, I am in the two roots, namely 3 and 3. 3 and 3, they are equal. Yeah. If they are equal, the procedure is multiplying 1x with the any one of the function. Understand? Multiply 1x because it is repeated twice. Suppose it is repeated twice, we can multiply up to x square. First term x to the power 0, second one x to the power 1, third one x to the power 2. Yeah. Now replace the root values 3, 3. So I am getting f1 of y plus 3x, f2 of y plus 3x. So there are two roots, so two functions introduced. But these two are real and equal. So I multiply x to the power 1. Right? Now what is pi? Now pi is 1 by d square minus 6 dd dash plus 9 d dash square of e to the power 3x plus 1. This is exponential type. So exponential type general formula is e to the power ax plus by. This e to the power ax plus by, replace d by the coefficient of x. What is the coefficient of x here? A. What's the coefficient of y? That is b. So that is b dash. Now in this given data, e to the power 3x plus y. E to the power 3x plus y. So let us replace d by 3 because the coefficient of x is equal to 3. Right? Coefficient of y is 1. So replace d by d dash by 1. So let us replace this one. I am getting that 1 by 3 square minus 6 into 3 into 1 plus 9 into 1 square of e to the power 3x plus 1. So please retain the term. Retain the term. Do not just forget the term after replacement. So we replace the particular values to the operators. That's why this is called particular integral. Got it? Now, what is 3 square? 9. 9 plus 9, 18. 18 minus 6 into 3, 18. 0. So here I am getting denominator 0. Here I am getting denominator 0. Same thing by 0 becomes, does not exist, infinity. So the whole becomes infinity. But that is not the case here because we have some PD. So automatically it will generate some solution. So what we can do, once the denominator is 0 in this case, the idea is let us differentiate the denominator with respect to d, the operator d. D square minus 6 d dash plus 9 d dash square of e to the power 3x plus y. At the same time, you see, when we differentiate with respect to d, what is the compensation? When you differentiate with respect to what's compensation? Integration. What is 1 by d stands for? Integral dx. What is integral dx? X. So when we compensate this by x, by multiplying the compensation value x. Right? I am going to differentiate this with respect to d. Now if I differentiate with respect to d, I am getting that it is 2d minus 6d dash. Clear? Because d becomes 1. There are no d here, so it is 0. E to the power 3x plus 1. Once again replace, because my ultimate aim is to get the particular integral when we assign the values to the operators. So still we have some operators here. Again the same idea, replace d by 3, d dash by 1. So I am getting that x into 1 by 2 into 3 minus 6 into 1 e to the power 3x plus 1. So once again I am getting 0. Isn't it? Once again I am getting 0, sir, here. Once again getting 0, what we can do? The same procedure, let us continue for the second time. Let us see that. How to continue? So let us, already we have the Pi is equal to x into 1 by 2d minus 6d dash. Now once again, differentiate the denominator with respect to d. Once again, denominator with respect to d. 2d minus 6d dash of e to the power 3x plus 1. But already we have one x here for the last time, right? Now this time, once again, when we differentiate this with respect to d, the compensation we multiply one more x. So x into x square. Got it? One more time, one more x. Now, after differentiation, what we will get? Dou by dou d of 2d is 2. There is no d here, it is 0. So e to the power x squared by 2 into e to the power 3x plus 1. Do you find any operators in the denominator? Nothing. So what's it mean that? That means that no need to substitute, no need to replace any value. So this is my required partial, that is a particular integral. So what is the complete solution? Is equal to complementary function plus particular integral. So this is my Pi. What about the complementary function? So complementary function is f1 of y plus 3x plus x into, why it is x into? Remember, because the roots are repeated twice. So that is why x into f2 of y plus 3x plus Pi x squared by 2 into e to the power 3x plus 1. So this is the final answer. I hope you may understand this problem, isn't it? Thank you for watching our YouTube channel ADC Max. Thank you.